Good day, folks. Welcome to my YouTube channel. This is the 2016 June exam. It's a national paper. I'm going to look at the photoelectric effect. In an experiment on the photoelectric effect, light is incident on the surface of the metal and electrons are ejected. That means the photoelectric effect occurs. 11.1.1, it says, what does the photoelectric effect indicate about the nature of light? It indicates the what? The particle nature of light. The photoelectric effect, it indicates the particle nature of light. Right, 11.1.2, it says the intensity of the light is increased. That means the brightness of the light is increased. Now it says, will the maximum speed of the ejected electrons increase or decrease or remain the same? Give reason for your answer. So the answer is what? Is remain the same. Right, the answer remain the same. The intensity, guys, from my other previous video, the intensity only influence the number of what? Number of photoelectrons ejected per second, not kinetic energy. The kinetic energy is not influenced by the intensity of light, which is the brightness. Now it says the wavelength corresponding with the threshold frequency is referred to the threshold wavelength. So the threshold wavelength that is corresponding to the threshold frequency is called threshold wavelength. Now it says, come on. Now it says, the table below gives the values of the threshold wavelengths of the three metals. We have a metal, silver, calcium, and sodium. These are the wavelength, threshold wavelength of them. So as you can see, the higher the wavelength, the faster or the greater the photoelectric effect, or the more the electrons are ejected there. In this experiment using one of the metal above, the maximum speed ejected of the electrons was as recorded as this. This is the speed of the electrons when the photoelectric effect occurred with above of the metal, one of the metal, and for the light of the wavelength of 420. So we're given that wavelength, which is it's 420 nanometers, which is -9 meters. 420 times 10 to the power -9. It says now identify the metal used in the experiment by means of suitable calculation. So by identifying that, you need to calculate the threshold wavelength that correspond with these ones. So we're going to use the formula. It's 11.1.1, 11.1.3. So we're going to use the formula that says energy of the photon is equal to the sum of the work function and the maximum kinetic energy. Right? So the energy of the photon, since we are given the wavelength, that means we can calculate it by saying Planck's constant C over wavelength. And then the work function, since we're given, what are we given for the work function? Okay, for the work function, we are looking for the threshold wavelength. So we're going to say Planck's constant times C over threshold wavelength. Yeah, you can do that. And then we are given the speed there, the speed of the photoelectrons. So we're gonna use that. So our unknown is this one, right? So we're going to substitute this side. Starting from this side, is 6.63 times 10 to the power -34 times the speed of light is equal to 6.6300 divide by the wavelength. It's 420 times 10 to the power -9, and it's 6. Here it's come on. This side it's 6.63 times 10 to the power negative 34 times the speed of light, 3 times 10 to the power 8, divide by the unknown. This is our unknown, plus half the mass, it's 9,11 times 10 to the power negative 34, and the speed of light is, the speed of light we're given, it's 476 times 10 to the power 5. 4,76 times 10 to the power 5, and then we square that, right? And then, guys, this is the maths marathon now. And then, so what we're going to do, we're going to take this answer, this to this side. No. We're going to take this answer minus this one here. So we're going to have the answer of that. I'm going to put it in this side. And then we're going to be left with 6.63 times 10 to the power negative 34 times 3 times 10 to the power 8 divide by the unknown. And then what do? We cross multiply. We cross multiply there, and then that's the maths. Our wavelength there, guys, when you punch the calculator, we're gonna get the answer for sodium. So it's gonna be 537 times 10 to the power negative 7, and then we say therefore it's threshold wavelength, therefore it's what? It's sodium. 11.2, it says a simplified energy diagram showing the possible electron transition in an atom shown below. So guys, if you look at the energy diagram, the first one there, we have the energy levels there. This is the highest energy level, and then in the energy level they decrease. This is the ground state, which is the lowest energy level, and this is the highest energy level. Same as this diagram too, highest energy level, lowest energy level, which is the ground state. They did not say it's ground zero there. Right now, guys, if you look at the energy level 1, as it stated, the energy increases as you go up, energy increases as you go up, energy decreases as you go down, right? But when the electrons, they move from the higher energy level to the lower energy level, as you can see, the Q and S, this one we call it we call it its emission spectra. Emission spectra, this one. What occurs there, because they're coming from the higher energy level to the lower energy levels. Now if you look at the diagram 2, the electrons, they're moving from the lower energy level to the highest energy levels. So we call this one, we're gonna call this one is a what? Is an absorption. They absorb. It's an absorption spectra. So for the electrons to move from lower energy level to higher energy level, they must what? Absorb energy. But for electrons to move from the high energy level to the lower energy level, the energy must be released there. Now it says here, now using the letter P, Q, R, S, and S, identify the line that correctly show the transition that will result in the atom giving the emission spectra. So the question is asking which one between the two that gives the emission spectra. So it's going to be Q and S. So the answer here, it's going to be Q and S. The answer of 11.1.2, Q and S. And then it says give reason for your answer. So your reason in Q and S, as I've mentioned, it's an emission spectra. What you will say? You will say the emission spectra occurs when electrons, you will say electrons fall back from the excited state to the lower energy level. Okay, let's say to the ground state. The excited state, guys, it's the high energy level, highest energy level. To the ground state, which is the ground state is the lower energy level. Guys, you're gonna write it correctly. That's the emission spectra, right? It's very important, guys. That's it. Cheers. Bye.